Hey everyone, and welcome to AppSec Fundamentals for the Modern DevOps. My name is Vickie, and today we're going to be talking about something that's really exciting and really important for the modern DevOps professional, application security. As we as an industry are producing more software faster and more frequently, securing applications have also becoming much harder. Because with every code release, you can potentially release a vulnerability that can compromise your entire application or your entire organization. And the complexity of modern applications and their deployment processes means that the DevOps professional needs to deal with security from time to time. So in this talk, we will be introducing the fundamentals of application security. We will first talk about the industry standard OWASP top 10 vulnerabilities, and then we will discuss the software development lifecycle and how you can implement security measures in each step of the process. And finally, my friend Suchakra will go through an example vulnerability and give you examples of what security measures can be implemented in each step of the development cycle to prevent that vulnerability. So let's get started. So the OWASP top 10 vulnerabilities are the top 10 vulnerabilities that affect web applications. And the first vulnerability on this list is injections, which includes SQL injections, which is what we'll be talking about in the second half of this presentation. And other common issues that happen to applications if they're not properly secured are things like broken authentication, sensitive data exposure, broken access control, insufficient logging and monitoring, and so on. We won't be going into the details of these vulnerabilities today, but these happen quite a lot, and these exist in most applications. It's just a matter of severity and what attackers can do with a vulnerability. And these vulnerabilities combined are the number one reason for data breaches in the United States last year, accounting for upwards to 40% of all data breaches that occurred in the United States. For instance, this SQL injection on Starbucks caused attackers to be able to leak the organization's accounting and financial information. And you're probably already familiar with the software development lifecycle, or the SDLC. The SDLC describes the 5 phases of application development: the requirement phase, the design phase, the code phase, the testing phase, and the release phase. You start by listing the application's requirements, and then you move on to designing the application structure and coding the application. And finally, you'll go on to testing the application, and finally releasing and supporting the application. So you might be wondering, what does this have to do with application security? When we look at the SDLC, we can also see 5 distinct chances of implementing security measures into the development process. And we ideally want to start considering security at the very start of the SDLC, starting from the requirements phase. This is what people mean when they mention shift left. Shift left means to perform security testing and checks earlier rather than later in the SDLC. So instead of integrating security tests into only the later phases of software development, like testing and release, we should also incorporate them into earlier stages of requirement, design, and coding. And the reason that you want to consider shifting left is that you want to consider AppSec at every stage in the development cycle. Serious security vulnerabilities often stem from small programming mistakes, and shifting left makes it easier and cheaper to find and fix security vulnerabilities in the application. And by considering security during the application's requirement and design phases, you can plan your security measure and find your security shortcomings before any significant effort is wasted in implementing insecure designs and insecure architectures. You can also make sure that you're allocating enough time and resources to security throughout your project's lifetime. And by conducting security testing throughout the coding phase, you can find security flaws while the implementation is still fresh in the developer's mind. It will make it much easier and much simpler to fix the bugs rather than later in the development cycle. And finally, you can better account for the time spent fixing security issues and avoid unexpected deadline pushbacks. So let's discuss how you can implement security measures in each step of the secure development cycle. Security measures into each step of the software development lifecycle. First, for the application's requirements and design phases, the key is really to think about how to factor in security when planning and designing the application. So starting from the requirements phase, one thing that you can do is to ask security questions from the very start when you are just starting to list out the requirements for the application. Make sure that you're accounting for security requirements as well. You should ask questions like, how will sensitive data be stored and transported? Where does this app need to take in user input? And are you using any third-party components? And which privileges should each user have on the application? And a good way to do that is to include security folks in the requirements phase so that they can look over the process and consider as many possibilities as possible when you're really thinking about the future security of the application. And the key to designing an app securely is to secure it from the very start so that security is not an afterthought and you don't end up patching security holes constantly after the application is built. So the next step is to plan the application design around the security requirements. So we can take the security requirements that we listed out in the requirements phase and then lay out the plan and figure out how to design the application around these requirements. In this phase, you're asking questions like, how should we implement authentication and authorization so that the people who have privileges can access the functionality and the people who shouldn't have privileges cannot? And how do we handle user input safely? How are we going to manage third-party components? How should we back up data and code? What protocols or encryption should we use to store and transport data safely? How do we manage sessions? And for this step in the software development lifecycle, you are planning out all the security measures that you'll be implementing in the next phase, the coding phase. And for the next step in the process for the coding phase, you can put in place measures that ensures that application development is being done securely. The first thing to do is to choose a secure programming language and framework. And you can also implement policies and guidelines of how to handle untrusted data safely via validation, sanitization, output encoding, and so on. And you should also put in place guidelines of how to implement proper error handling and logging in the application. Having these detailed guidelines and policies for developers during this phase will drastically reduce the number of bugs found later in the development cycle in the testing phase, and it will be much easier if you squash the bugs during this phase instead of play catch-up in the testing and release phases. And next up in the application testing phase is all about implementing a wide variety of tests to test your application's implementation and making sure that no severe bugs are gonna make it into production. And this phase should really not be where your security effort starts. We see that a lot in the industry where people implement most of their security measures during the testing phase instead of earlier. But this phase should really be a fail-safe to catch the vulnerabilities that slip past your security protocols implementing earlier during your development cycle. So one thing that you can implement is first a manual code review. During this review, you have developers cross-check each other's code to see if secure coding practices are being followed and if any bugs can be spotted. You can also use a SAST or static analysis security testing tool to speed up the process. SAST tools automatically identify vulnerable patterns of various vulnerabilities using code scanning. And so it's a really good tool to help you automate a lot of manual code reviews and make the process even faster. You should also use an SCA tool or software composition analysis tool. SCA tools keep track of an application's dependencies and alert you if new publicly disclosed vulnerabilities are found in your application. And finally, you can use DAS tools or dynamic analysis tools, penetration tests, and bug bounty programs as sort of a last layer of defense. They're a good addition to SaaS tools and SCA tools to find more vulnerabilities in your applications by testing the application with malicious input. But they really shouldn't replace SaaS tools and SCA tools, as SaaS tools and SCA tools tend to have much better coverage and can find a much wider extent of vulnerabilities in your applications. So one more thing to note is that these scanning tools are not 100% accurate. So the best way to build secure software is to use these tools to find potential vulnerabilities and then conduct a manual review to validate them. This way you can make sure that as few bugs as possible make it to production, and you can also save a lot of time by not performing the first round of manual review by yourself. And finally, for the last phase of the software development lifecycle, pay attention to the security of your deployment pipeline. Recently, there's been many instances of attackers compromising the deployment system to compromise the integrity of the source code of the application. These are also referred to as supply chain attacks. And a software supply chain is all the tools that you need to make your software. Things like repositories, package managers, scripts for deployment, and open source components. And supply chain attacks refers to attacks that targets these tools or these components. Making sure that the deployment tools that you need are vetted and secured is crucially important. You can also build in routine security tests such as dependency monitoring and SAS scans into the applications so that the application can continue to be monitored after deployment. So this concludes the first half of our presentation and a high-level overview of what you can do in each step of the software development lifecycle to secure your applications. And now, my friend Suchakra is going to go through an example of how these measures can be implemented throughout the development cycle to help prevent a specific vulnerability in the OWASP top 10. Specifically, we're going to be talking about SQL injections.
Okay, thank you, Vickie. So let's dig a little bit more deep into SQL injection. What could happen is that you have some statements like this inside your code, where a query string can contain the whole query along with the variables that are just concatenated directly inside the whole query. Do note the locations of quotes before and after, towards the start and the end of the whole query string. And then that whole query string can be taken and that is directly executed using sql.execute query. So this is just an example for Java. It can be the same in any language. So now in a normal case, what would happen is that there's an HTTP request. You're probably making a post request to the login route. And you are passing the username and password along with that. And the way you are doing it, or the way you have to think from the attacker's perspective, the way they would be doing it is now they are going to play around with the variables username and password because you're directly using them like this. And as you can see, they are just going to be concatenated. So this is a normal use case, what might be happening when a normal user is using. But what could be done is that an attacker can try to play around with the string. So the username string here, they have used admin single quote semicolon dash dash. And if you try to place it back, you will see that the admin code single player dash dash and then there's a quote. So the quote before the admin and the after the admin, they make this the complete string, and then everything else after this is not used anymore. And so now suddenly you were supposed to give a username and password, and now what you are left with is that select ID from users where username means admin. This is a true query, and suddenly you have escalated privileges. Now you can do anything with the database if you have admin as a user inside the database. And that usually happens. So in real cases, there would be these thousands and thousands of variations you could give to these SQL statements, and then the attackers would keep on trying again and again until they actually reach one of these statements which are written, coded like this. So we have to think about how to prevent this. So this brings back again to the whole concept of having security embedded in the SDLC right from the beginning, shifting towards the left. And it starts with requirements. So in requirements, you would want to first understand what is the sensitive data, where is it going to be stored, how is it going to be transported, and then where is this app going to use this sensitive data? How is it going to make the database calls? How you are going to use the inputs? Are you even going to need those user inputs which are there? And once you have decided on those requirements and thought from it from the security perspective, you would move to design. And in the design, you have to take care of all the considerations which are there. For example, what mechanism should be used if the users are going to input it. Are you going to use a library which has this nice user input feature here? A form is there where username and password is input, or any other information is input. Are there any empty forms, forms which are not supposed to be there? You have to think from that perspective. Are on the inputs which are being given in those text boxes, are you using input validation, sanitizing, or escaping? Is that required? So you would think from that perspective. Are the database calls okay? Are they secure? What's the least privilege needed for an application to run? You may not even need the application to have a username and password at all. So you have to think about all these aspects of it. And in case there is a breach, in case something happens, are you going to back up the data? What if the admin user escalation happens, the SQL injection happens, and somebody deletes the data? So you have to think from all of these perspectives. Which then brings us to the code side of it. So once you have done the requirements and the design and analysis is done and the code is implemented, you have to think carefully. You have to understand where you're escaping rejected dangerous characters which might be there, implementing proper prepared statements. So this is one very easy way where you can use prepared statements and not just concatenate strings the way we were doing here. And this way you would be able to actually mitigate the chances of an SQL actually happening. And then you implement the privilege of least implement the principle of least privilege. You secure the data, when you're using it, when you're storing it, whatever variable is coming, you have to think about, is it going to go to a log? Are you saving it securely? And the database implementation that you're using, is that correct, or it's not correct. So you have to think from all these perspectives. Then we come to the testing. So once the code is done, it's ready. We have to test it from security perspective as well. So a manual code review is one of the most important ones, which you should always run. That's usually there these days in companies, but you have to think from a security perspective now. Same with SAS scanning for signatures of SQL injection. So a SAS tool could be run which checks the signatures. It's a very common and a very straightforward thing to do. And then SCA, so use component analysis, and you understand what third party components are being used inside your code. Are they secure? Are you using an old library, an old ORM library which makes SQL statements, and is that secure? We have seen these things in the past as well. And then move all the way to the release. So at the release time, you again run security tests in the pipeline using SCA, lightweight SCA, or SAS scans, which are run. Implement bug bounty programs, encourage people to come in and stress test your application, security test your application, and regularly backup important data and code, and then monitor the application for potential attacks. So have some sort of systems where an attacker can try to enter the application, you are able to monitor all such events. And that's basically it. We have gone through all the systems, all the way from the SDLC, and seen how for SQL you can implement these situations. And it's the same for all of the cases that were there before. Thanks a lot, and I encourage you to go and visit all the attack scenarios that were discussed by Vickie before. Thank you.